This is a video for homework 6 on number 12. So this one has to do with residual plots and what they kind of represent and how they show if there is a linear pattern or not. And it may be kind of strange, but I'm going to show you also a little website that I like that kind of explains your residual plots in a great way because it shows you different pictures. So we have the following data represent the time between eruptions and the length of eruption for 8 randomly selected geysers. So here we have the time and the length, and again, this might be a little strange because it's split up, but it's instead of having one big table like that. So I want to say what type of relation appears to exist between time between eruptions and length of eruption. So first let's view the scatter plot, and just click here to view the scatter plot. So if you look, it appears like we have a linear relationship. It appears that I could possibly go ahead and draw a straight line through these data and it'd be a pretty good fit. Now the reason it would be positive is because it's rising from left to right. If it were going down from left to right, that would be negative. But here it looks like it's rising from left to right. So that's why we choose that it appears to be a linear positive association. Now we want to see if the residual plot confirms this relationship. Now I know that it's weird, but we're just going to go to the residual plot definition here. I'm sorry for any ads at the top. But this website gives a nice little definition of your residual plots. And hey, an SNHU ad, isn't that funny? But also it can really help to see what these look like. So a residual plot is a graph that shows the residuals, which is basically the distance between the line of best fit on the horizontal axis. So what we have here is that this random pattern actually indicates a linear model. Isn't that strange? So if you have a random pattern that looks sort of like this, you can't draw a line through it, you can't make any sort of pattern form it, that actually indicates that you have a linear model. If instead you have something like a U shape, or something that goes down like that, or maybe it actually is a linear shape, like who knows, but you can actually draw something into it, it may be better that you have a different nonlinear model. Like maybe it's better to be a quadratic model or a cubic model or something else of the sort. So we're looking to see, we want to see something like this to confirm a linear pattern. So let me go back to my do homework, and I'm going to click on the residual plot. So if you look here, I really can't draw a line through that. There is not really a U shape going on here, like no discernible U. There's some above the horizontal line, there's some below the horizontal line, doesn't seem to be any clear pattern. So that's why I'm going to click yes. The plot of the residual shows no discernible pattern, so a linear model is appropriate. Now next, we have the coefficient of determination. Now, what does that represent? So again, you can go back to your text. My favorite thing when I'm not sure what a definition is I go to the question help and I click view an example. And the reason I like this is because it's very much like, I'm just going to keep going and clicking continue here. It's very much like a regular textbook and will kind of give you some nice things that you can read that will help you to discern what that means. So let's just talk here. The coefficient of determination. Okay, first of all, it measures the percentage of total variation in the response variable. So this is not something that you're calculating right now, although you can calculate it in StatCrunch, but they've already calculated it for you. Okay, so if I were going to do that, you know how we talked about the, R value, which is the correlation coefficient, R squared, so I just take my R value and I square it, is the coefficient of determination. And in this case, again, I do not have to calculate it. It's already given to you. So it's going to tell me what percentage of the variation is found here. So if I look here, it says the coefficient of determination in my case is found to be 94%. So it says the least squares regression line explains, and what you just type in is exactly what you have here for the 94%. 94% of the variation in length of eruption, because it's going ahead and it's showing you the variation, the percent of variation from the least squares regression line. It explains 94% of the variation in the Y variable, and that Y variable is length. Okay, so again, use that question help. I like it because sometimes that new interactive textbook can be a little bit confusing and a little bit hard to find things without clicking through, whereas doing that question help and going directly to show me an example gives you kind of a textbook definition. Let me know if you have any more questions on that.